And welcome to my homework rewards. Today we're going to solve a moment question, 323 from Statics and Mechanics and Materials, 2nd edition by Hibbeler. So the question reads, as part of an acrobatic stunt, a man supports a girl who has a weight of 500 newtons and is seated at the top over here. Her center of gravity is at G, which is 5 meters away. And the man is able to exert a moment counterclockwise of 350 newton meters. We want to determine the maximum angle of tilt theta, which will allow the girl not to fall. And it gives us specifically so that her clockwise moment about A does not exceed the 350 newton meters that the man can exert. So what exactly is happening here? Well, we have a lady at the top, and her mass is going to exert a force on the pole downwards, gravity, which is going to cause it to rotate this way. The man on the other side is providing the counterbalance, essentially, 350 clockwise moment this way. So the question is asking, what is this angle theta that basically allows this pole to be in equilibrium so it doesn't fall over? So the steps that we're going to take are, first we'll draw a free body diagram of the pole. Next we'll set up equation of moment about point A. The question kind of hints to that. And lastly we'll solve for theta. So let's draw a free body diagram. We have a pole, and the girl is exerting a force of gravity, which goes downwards, 500 newtons. Now we also know that the man, and this was point G, we also know that at point A, the man is exerting a counterclockwise moment. So that's this way. We'll call it moment, we'll just leave it as an M, and that's at point A. And we know that that is equal to 350 Newton meters. So you can see that this force over here, the gravity force, is going to cause the pole to rotate in the clockwise direction. And the moment that the man is applying is going to be in the counterclockwise. So they're going to balance each other out. So this is what our free body diagram looks like. We also know that there is an angle over here, theta. And from the Z pattern, we know that these two angles are going to be the same. So what that also means is that this force over here is also going to be theta. So now we have the free body diagram. We'll write an equation for the moments. Before we do that, for convenience, let's actually express this force of gravity as two different forces. The first one is going to go along the direction of this pole, and the second one will be perpendicular. If you recall, the properties of moments basically says that you can take a force and break it up into different components and find the moments from each one of those forces, add them together, and that'll be the same as the original force. So if we take the moment produced by these two forces over here, it'll be the exact same as the moment from this force. And the reason why it's convenient is because this force over here goes along point A. So that means the moment is actually 0. And now we just care about the perpendicular portion of the force, Fg. And because it is opposite of the angle, it's going to be Fg sine theta. So let's write out the equation for the moment. We're going to take the moment at point A, and we'll take it in the counterclockwise positive direction. We'll set this to 350, which is the moment M, which is what the man is exerting, minus the perpendicular force we said was 500 sine theta, and it's being exerted at a distance of 5 meters. which is basically the distance from A to G. Now we'll set this equation equal to 0 and solve for theta. The question asks what's the maximum angle of tilt. So once we solve for this equation equal to 0, we will discuss whether or not the angle can be greater or less than that. So here we just need to rearrange, and we end up with sine of theta is equal to 350 divided by 500 times 5. So that means that theta is just sine inverse of that fraction. Or theta is equal to 8.05 degrees. So let's go back up to our question and see what that means. That means at an angle of 8 degrees, basically the moment that the man is producing will be exactly equal and opposite to the moment produced by the force of gravity from the girl's weight. Now, can we have an angle larger or less than theta? Well, if you recall, the force that matters for the moment is 500 sine theta. So as theta gets smaller, this force will actually get smaller as well. Remember that sine of theta starts at 0 and increases. So now the man can exert a maximum moment of 350 newtons, which means that if the angle was a little smaller, he wouldn't have to exert that maximum force. So all in all, the solution to this is theta can be less than or equal to 8.05 degrees. And there you have it. We drew a free body diagram for this scenario. We wrote the moment equation about point A and solved for theta. Remember that you can download the solution to this problem at MyHomeworkRewards.com. The link will be in the description below. And if you're looking for a personalized solution that has tutorials and practice questions, then check out MyHomeworkRewards.com. You'll also be able to earn rewards as you practice homework questions. Thanks, have a good one.